Analytical vector addition. Here are your priming questions. To add our vectors analytically, there are a few basic principles that we need to follow. The first is when we're doing our math and actually adding the different vectors together, we can really only add our vectors that are perpendicular to each other. And so if they are not perpendicular, we need to break it up into its perpendicular components. Typically we call this x and y. And the way we do that is using SOHCAHTOA. And this will be with your sine, cosine, and tangent functions that I've shown you here. And if you don't remember these, we'll go through it quickly in this video. If you have more questions, we can go through this more in class as well. Once you break it up into the x and y components, then you add all of your x's, and then you add all of your y's. You do this separately. And then from there, you draw your final triangle with your final x and your final y. And then you have your final resultant, and you find your angle using your inverse trig functions, which I will also show you. So sine of theta is equal to opposite over hypotenuse. The theta is your angle, sine is the function, and then opposite and hypotenuse refer to the sides of a triangle relative to the angle. And I'll show you this in just a moment if you aren't familiar with it yet. Cosine of theta is equal to adjacent over hypotenuse. Again, these are the sides of a triangle. And then this is angle and cosine. And then tangent of theta is opposite over adjacent. I always just remember SOHCAHTOA, and then I work from there. So let's do these two practice problems. We'll start with the first one. 2.3 meters, 25 degrees north of east. The first thing that you want to pay attention to is the angle and the bearing so that you know where you're measuring your angle from. In this case, we're going north of east, which means that if this is our vector, we are measuring this angle, and this is 25 degrees. And so now what we need to do is we need to find the x and y components. And I'm going to draw those in for you here. So this would be our x, and then this would be our y. And the way to think about this is before, if we had this x and y vector separately and we added them together, they would produce this resultant. Right now what we're doing is we're going backwards. We're starting with the non-perpendicular, breaking it up into the x and y components. And so these two components are essentially equal to this non-perpendicular vector. So let's go and get started with this. We're looking for x and y components. We have to find them separately. And so we start by looking at this x. So if we have this x, relative to the angle, we are adjacent, and we know the hypotenuse is 2.3 meters. So we're looking for the adjacent, we have the hypotenuse, and we have the angle here. And so in this case, we want to use cosine. And so we would have the x component is equal to 2.3 cosine of 25. Now, what you want to be careful of with your calculator is, in this case, we are measuring our angle in degrees, so you need to make sure that whatever mode your calculator is in matches our measurements. So here we're measuring in degrees, so you need to make sure that your calculator is set to degrees, and you should get your x component is equal to 2.1 meters. And now, if we're looking for our y component, actually let me go and label these. If we're looking for our y component, we can see that that's going to be the opposite side compared to the angle. And so we're looking for our opposite. We now have our adjacent and our hypotenuse. And so we can use either our sine or tangent in this case. Most typically default to sine. So in this case, when we rearrange this, this would be 2.3 sine of 25. And also, I forgot to mention why these are written out the way they are. In this case, actually, let me show you with the y now. So the y is equal to 2.3 sine of 25. This came from this function over here. Sine of theta is equal to opposite over hypotenuse. And in this case, we would do the hypotenuse, move it over. So our hypotenuse was 2.3. Multiply both sides by that. So we have 2.3 times the sine of theta is equal to the opposite, which is what we're looking for. I can show you this more in depth in class as well. When you work this out, you should get y is equal to 0.97 meters. For the second practice problem, 4.2 meters, 81 degrees west of south, I have it drawn out over here. Now, what you'll notice is that these are roughly going in opposite directions. So what we have to be careful of now is our frame of reference. And what we want to do is we want to establish our positive direction. So let's go and say that up is positive and to the right is positive. And if we look back at our other practice problem, everything is positive there, so we don't need to worry about it too much. But now, when we work out this vector, what we have to be careful of is what we notice is it's going to the left and going down, which means that both of those vectors are going to be negative for us based off our frame of reference. And so let's go and start working this out. We have 4.2 meters. We're 81 degrees west of south, and so we're measuring from south, and we are going west. And this is 81 degrees. Now, with where we've drawn our angle now, we wanted to go and draw our x and y components. And so, we want to draw our x and y components. So it would be here and there. And let me go and change the colors of these. Change the color so that you can see them a little bit better. Like that. All right, so we have our y vector going down, so we know it's going to be negative, and we have our x vector going to the left, which will also be negative. And so now, when we look at this and we think back to our sine, cosine, and tangent functions, if we want to look for our x component first, we see that our x is opposite of our angle. And so, if we look back at our functions, since it's opposite, we'll need to use our sine for our x in this case. So this would be our x is equal to 4.2 sine of 81 degrees. And when you work this out, you should get x is equal to 4.2 meters. Now, your calculator will give you 4.2. We know that this is going to the left, so we know that this is going to be negative. Now, let's look at our y. Our y is adjacent to our angle now, so we're going to be using our cosine. So y is equal to 4.2 cosine of 81 degrees. So our y is equal to 0.66. So that's what your calculator is going to give to you. We know that that's going to be negative. All right, let me show you the inverse function. So to find the angle at the end, we need to figure out what sides we have for the x and y's, and then we use our inverse function based off of that. In most cases, you'll be using your tangent, but you don't always have to. Let's go and use the tangent as an example, though. So we have tangent of theta, and really this should be in parentheses to help you understand this, is equal to opposite over adjacent. So from here, if we're looking for our theta is inside of the function of tangent, and so all we need to do is do the inverse function so that we can get our theta out of it, but we need to do that to both sides. So what this becomes is theta is equal to the inverse tangent of opposite over adjacent. And this main idea can apply to both cosine and to sine as well. Let's do a practice. So find the resultant of these vectors. So we're going to start easy. 2.3 meters north and then 4.2 meters west. So if we are working with these, we have 2.3 meters north, and then we have 4.2 meters west. And if we want to go and draw our resultant, it'll look like this. And remember that there are multiple ways that you can be working on these. And so with this, my angle would be there. And let's go and write in our value. So we have 2.3 meters, we have 4.2 meters. And so now, our components are already in the x and y plane, so we don't need to worry about breaking them up. We can add these directly. And so we have our resultant here And we can use Pythagorean Theorem. So we have a squared plus b squared is equal to c squared. So we can find our hypotenuse. And when you work this out, we should get 2.3 squared plus 4.2 squared is equal to c squared. We should get c is equal to 4.8 meters. So this is going to be 4.8 meters. And now, with the way I've drawn my angle here, I'm using north as my frame of reference. I'm measuring west of north. And so, let's go and use our inverse tangent function to find our angle. So theta is equal to the inverse tangent of opposite over adjacent. So that's going to be 4.2 over 2.3. Remember, this is opposite to the angle and then adjacent to the angle. And once you do this, you should get your theta is equal to 61 degrees. So we would rewrite our final answer as 4.8 meters at 61 degrees. This is west of north. Remember, we're measuring from north and we're going west. Let's do a practice with two non-perpendicular vectors before we move on. So now, rather than just being north and west, we have 25 degrees north of east and west of south. What you'll notice is I've copied the vectors from the previous practice, and so we can go ahead and go back here, and let's go and just copy these and move from there. So for this first one, remember, these vectors are exactly the same, so our components will be the same as well. And so now, I've copied these in. We have our two sets of vectors. I'll move these off to the side so you can see that they're separate. So we have one set of vector, the 2.3 meters, 25 degrees north of east. That's going to be 2.1 meters in the x, positive, and then 0.97 meters, positive in the y. And then our 4.2 meters, 81 degrees west of south, we said it's going to be negative 4.2 meters in the x, and then a negative 0.66 meters in the y. Now, what we want to do is we want to add up our x's and y's separately. And let me use a different color now. Let's use blue. So we have our x column, and we have our y column. And now, for our x, we have a positive 2.1 meters. So we have 2.1. And we also have negative 4.2. For our y's, we have a positive 0.97 and a negative 0.66. And so what we want to do is we want to now find our final x and final y. And so when we do that, we're going to add these up. We get 0.31 meters in the y and a negative 2.1 meters in the x. So now we have a single x and a single y, and then from here we can draw these out. We know that this is going a negative 2.1 in the x, so that's going to be going to the left, and a positive 0.31 going in the y. Let's go and move that here. And so we could draw our resultant like this. And with the way I've drawn this, the angle would be right there. And that's going to be our theta. All right, and let's go and label these vectors as well. So this is going to be 2.1 meters to the left. This is 0.31 meters going up. You'll notice that I've dropped the negative here because we were already showing the direction with the vector there. And so we use Pythagorean Theorem again to find our resultant. 0.31 squared plus 2.1 squared is equal to c squared. So our c is equal to 2.1 meters. So we can draw that in. We have 2.1 meters. And now we need to find our angle again, so we are going to use tangent again. So we have theta is equal to the inverse tangent of, in this case, where we have this here, opposite over adjacent. Opposite is 0.31 over 2.1, that's the adjacent. And we get theta is equal to 8.4 degrees. And we've measured this from west going north, so this would be north of west. And so if we were to rewrite this out, what we would get would be 2.1 meters at 8.4 degrees north of west. For your own practice, try to add these three non-perpendicular vectors. At least attempt this and check your answers in class. And here are your priming questions.